On this video, we're going to talk about other electron configurations and we're going to look at some end of chapter example problems. Let's start by looking at the spectroscopic electron configuration. It uses a shorthand notation to represent the way the electrons are distributed in the orbitals, and we write down each sublevel with the number of electrons in that level as an exponent of the sublevel. For example, in 3p to the exponent 3, the 3 represents the main energy level, the p represents the type of orbital, and the 3 in the exponent represents the number of electrons. For example, for a hydrogen atom, we have only one electron and it is in the first energy level. So we're going to write its electron configuration as 1s1. The 1 represents the main energy level, which is the first energy level. The S represents the type of orbital. Is it an s orbital or is it a p orbital? So in this case, it is an s orbital. Then the 1 in the exponent represents the number of electrons, which is just 1 for hydrogen atom. Then we move on to phosphorus. Phosphorus has 15 electrons. How do we know this? Because it has 15 protons and it is a neutral atom, so it is going to have the same number of electrons as the protons. So write its electron configuration as 1s2, 2s2, 2p6, 3s2, and 3p3. So you can check if your answer is correct by looking at your valence electrons. For phosphorus, it is in group 5, so we know that in our outermost energy level, which in this case is the third energy level, we need to have 5 electrons. And in this case, we do have 5 electrons because in 3s orbital, we have 2 electrons, and then in the 3p orbitals, we have 3 electrons. Let's move on to the shorthand electron configuration. In this type of electron configuration, we replace the inner electrons of the element with the preceding noble gas, followed by the outermost level with the valence electrons. For example, for a carbon atom, we have 6 electrons, and the preceding noble gas for carbon is helium. So we're going to write the electron configuration for carbon as helium in square brackets, 2s2, 2p2. You can also check if this is correct by looking at your valence electrons, because we know that carbon is in group 4, so it should have 4 electrons in the outermost energy level, which is the second energy level in this case, and it does have 4 electrons, so it means that your electron configuration is correct. And helium has an electron configuration of 1s2, so you can pretty much see that your electron configuration is correct, because if helium represents 1s2, then you will have in total 6 electrons for carbon. Then we move on to potassium. Potassium has 19 electrons and the preceding noble gas is argon. So you're going to write Ar in square brackets followed by 4s1. And potassium is in group 1, so it does make sense that our outermost energy level only has 1 electron. Let us look at end of chapter example problems. Question 1 is on the standard notation. So we should use the AZE notation and give the number of protons, neutrons, and electrons of the following elements. The first element that they gave us is K1939. The 19 represents the number of protons and the 39 represents the atomic mass number, because remember I told you that the number of protons is always lesser than the number of neutrons. So in this case, for potassium, number of protons is 19 and the number of neutrons is going to be 39 minus 19, which is equal to 20, and the number of electrons is equal to 19 because potassium is a neutral atom, and so the number of protons should equal the number of electrons. Let's move on to barium. Barium has 56 protons and the number of neutrons is equal to 137 minus 56, which is 81. And the number of electrons, again barium is a neutral atom, so the number of protons should equal the number of electrons, which is 56. The second question is still on standard notation, but now we're using the standard notation to represent the isotope of chlorine atom with 18 neutrons. In this question, we're given a number of neutrons. This might not always be the case. We might not be given the number of neutrons, so you should remember that the number of neutrons is equal to the atomic mass number minus the number of protons. So first we get the symbol for chlorine atom, which is Cl, and then we get the number of protons from the periodic table, which is 17. Get the number of neutrons we're already given, it's 18, and the atomic mass number is 35. Therefore, our standard notation will be Cl, 17 at the bottom and 35 at the top. But it could be still 35 at the bottom and 17 at the top. It depends on how they want you to write your notation. In this case, they told us that our A should be at the top and our Z should be at the bottom. So that is why we wrote it this way. In another question, they might say that your Z be at the top and your A be at the bottom. It doesn't really matter. You just need to know that your Z represents your number of protons and your A represents your atomic mass number, and that your number of protons is always lesser than your atomic mass number. Then we move on to question 3, which is on relative atomic mass. Here they're telling us that a sample of the element lithium has 97% biomass of the isotope of lithium with 4 neutrons and 3% of the isotope with 3 neutrons. What is the relative atomic mass of the sample of lithium? So in this question we're given the abundance of an isotope with 4 neutrons. If it has 4 neutrons, it means that it has an atomic mass of 7, because lithium has 3 protons from the periodic table. And the abundance is 3% for the isotope with an atomic mass of 6. Again, when I get the 6, it's 3 plus 3, 3 neutrons plus 3 protons. Therefore, our relative atomic mass will be calculated as 97 multiplied by 7 plus 3 multiplied by 6, all divided by 100. Our final answer is 6.97. So remember, do not undermine this. If you do not practice, you will forget. So make sure that you practice this before a test or before an exam so that you remind yourself. Question 4 is on isotopes. We want an isotope of 14,6 carbon. The 14 represents the atomic mass number and the 6 represents the number of protons in carbon. Is it going to be the 12,6 carbon, the 14,7 carbon, the 12,7 carbon, or the 14,6 carbon? Remember, what doesn't change in isotopes? So the number of protons doesn't change, it remains the same. The only thing that changes is the atomic mass number. So we have 2 carbon atoms here with the number of protons of 6, the first one and the last one. But if you look at the last one, the number of the atomic mass number is still the same, so it cannot be that one, because in isotopes the atomic mass number is different. So it must be the first one, because they have the same atomic number but different mass number, meaning that the number of neutrons is different. Okay, let's move on to question 5, looking at electron configurations. We are given 3 elements, P, Q, and R, and their electron configurations. P has an electron configuration of 1s2, 2s2, 2p5. Q has an electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p1. R has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p4. So you should say for each of the elements if it is more likely to form a cation or an anion during ion formation. And then you should indicate the valency of an atom of the element. For P, it has 7 electrons in its outermost energy level, which is the second energy level. So is it most likely to gain an electron or lose an electron? It is more likely to gain an electron because it is trying to fill the nearest energy level, which in this case is the second energy level, because it has 7 electrons in the second energy level, and the second energy level can hold 8 electrons. So it's like the element is saying, why should I lose all my 7 electrons to stay in the first energy level? I'd rather gain 1 electron than to lose all 7. So it gains 1 electron to stay in the second energy level, to fill the second energy level. So it is going to form an anion, and its valency will be -1 because it gains 1 electron. Then for Q has 3 electrons in its outermost energy level, which is the third energy level, and it is going to need 5 more electrons to fill the third energy level. But it can lose 3 electrons to stay in the second energy level, to fill the second energy level. So Q would rather lose the 3 electrons than to gain 5 other electrons. So it loses 3 electrons and it forms a cation, and its valency is +3. R has 6 electrons in its outermost energy level, which is the third energy level, and so it needs just 2 electrons to fill the third energy level. So it is going to gain 2 electrons rather than to lose the 6 electrons that it already has on the third energy level. So it's going to form an anion, and its valency will be -2. That is it for this video. On the next video, we'll start with chapter 4, looking at the periodic table.